the context for Submariner is so Kubernetes just in general, and so Kubernetes has this model of clusters which have clear boundaries, and that's a good thing because it helps administrators manage services, and it helps model security in particular. But in some cases, you want to be able to connect different clusters, and so that's possible as is with Kubernetes. If you configure a service to be published using a load balancer or a gateway, and there are ingress and egress resources that allow you to control access from one cluster to another, but that takes quite a lot of work, and it doesn't really scale as the number of services that you want to share goes up. And it also means configuring everything to be public, which you might not want. And so there are lots of circumstances where you want to connect Kubernetes clusters. Some have been mentioned already, but you can have, it could just be for scalability reasons. If you have very large Kubernetes clusters, they start to become unmanageable, and so you might want to split your computing resources across different clusters, but still be able to connect them. You might have legal reasons to split clusters. For example, if you have data that has to stay in a specific geographic location, but you want to be able to use computing resources in another geography because it might be cheaper, for example, or you have more available, then you'd want to connect clusters then. Other circumstances are, for example, if you have an on-premise cluster using your own hardware, but that scales with difficulty because you have to be able to buy more hardware, and especially recently that's been complicated. And so you might want to use clusters in the cloud that are more elastic, but you want to connect them as well. And so that's where Submariner steps in. It's one of a number of projects that do similar things, but Submariner provides connectivity between clusters. At the networking level, it provides a shared data plane across clusters with encryption by default. So it's all secure, but all your pods basically can see each other across clusters, and pods can see services across clusters. And I'll show that in just a little while. It also provides service discovery across clusters, and this is a concept that's shared with other systems. It comes from what's called the multi-cluster services special interest group in Kubernetes. And the idea there is that you can make a service available across multiple clusters, and it can be deployed in various clusters as well. It doesn't have to be in just one or in all of your clusters. It can be in a subset, and each cluster will use whichever one is appropriate. And so it does that as well with the ability to take care of old deployments, old clusters that haven't necessarily been set up to provide connectivity initially. So if you've set up multiple clusters historically, there's a good chance that they'll have overlapping network resources. So share the same IP addresses, which makes them difficult to connect. And Submariner deals with that as well. So enough about Submariner. I'll come back and explain what it does and how it works in a little more detail as we go through the demos. But just to show you how it's used and what it does, I've set up 2 clusters here. So this is on AWS running OpenShift. So I've got Athens 1 here and Athens 2. And just before I set up Submariner, just to prove that the 2 clusters aren't connected, I've set up Nginx on Athens 1. So you can see it here. Nginx Demo with 2 pods, and I have NetShoot. So these are containers with a number of networking troubleshooting tools that we use, and that's available on both clusters. So if I connect to to one of the NetShoot pods, the one that's on, sorry, I'll start with Athens 1. So on Athens 1, as you'd expect, the Nginx service is accessible. So I can do curl Nginx Demo, and I get the welcome page back. I can also do that with the service's IP address, which I have here, and I get it back as well. And if I do the same thing from the other cluster, I'll try first with the service name, and it doesn't know about it. And if I try with the IP address, it will just sit there for a while until it times out. So that shows that there's no connectivity between the two clusters. So I'm going to set up Submariner, and I'll show you the commands I use just a little later when I share my terminal. But we have this. We have a tool that's called Subcuttle that we use to deploy Submariner. So the first step is to set up a broker. So there's a specific command for that, but it's really easy. Just Subcuttle deploy broker, and I'll show you what it does. We'll watch the deployments. So currently we only have the default namespace and all the OpenShift namespaces, but this will create a new one, which should appear. So if I look in the event log here, see things happening. Yeah, except I'm looking on the wrong cluster. Right, so see here, 1801, there's stuff happening. And so if I go and look at the deployments in the projects now, we have two new namespaces that have appeared, Submariner KTest Broker and Submariner Operator. So everything is actually, so I'm using a tool, Subcuttle, but everything is actually driven by an operator, which is Submariner Operator. And what that does for the broker, and I'll explain what the broker is in just a second, is it creates a number of CRDs. So if we look at the namespace itself, there's nothing actually running there. But if we go and look at the CRDs that are deployed, there's a new one here called cluster, and another one called endpoint, and another one called gateway. And you can see here submariner.io, so they're ours. So why did I start by doing this broker deployment? So let's go back a little bit to the Submariner's architecture. So here you have a diagram that corresponds pretty much to the situation I've set up on OpenShift. On the right-hand side, we have Athens 1, effectively. So one cluster, which is going to talk to the green cluster here, which is Athens 2 in my demo. And you can see in the top left-hand corner of the orange cluster, there's a broker diagram. So this is what Submariner uses to share information about the clusters across all the connected clusters. Because obviously, if you're trying to connect multiple clusters together, the clusters that you want to connect, they have to know about each other. And so this is how Submariner does it. So we have one of the clusters in the set, or it can also be a dedicated cluster, which has to be accessible to all clusters. So typically it will be a cloud-based cluster instead of an on-premise cluster. And it's used to store data just in a number of CRDs. So there's no Submariner-specific intelligence here. We're just relying on Kubernetes as a sort of database. And we push information to the in the CRDs. So every time I'll connect a cluster, we'll add information about the cluster, how to connect to it, and so on to the broker. And then that data is synchronized to all the participating clusters, and they open all the connections that are required. as appropriate. So I'll come back to this diagram in just a little moment, but the second step in the setup is to actually join clusters. And so there's another command to do this, which is just subcuttle join. And to see what happens here, I'll watch the deployments in, or even the pods in the Submariner operator namespace. So let's get started. So it starts by checking that the operator is actually running. There. So now it started creating other pods, a bunch of them. So the first one is the gateway. Then we have Lighthouse components, and I'll explain those a little later, and root agents, a whole ton of them. So what do these all do? And back to the architecture diagram. So the first one I showed you was the gateway. Well, obviously there's the operator that orchestrates everything, but this doesn't appear here. So then there's the gateway, and this is the component that actually takes care of the network connectivity between the clusters. So inside every cluster, one node has to be designated as a gateway, and that's where the tunnels will be established. So it runs the gateway. This retrieves the information from the broker. And so currently we only have one cluster in the connected set of clusters, so there's nothing to actually do. There's no tunnel to establish. It doesn't do anything. But once there are other clusters to talk to, it's the gateway node that will take care of setting up the tunnel. Then there's the root agent, and that's and you saw that there's lots of them, and that's because there's one per node inside the cluster, and that's the component that takes care of getting the traffic from inside each cluster to the gateway node and across to the other clusters. And so it sets up networking routes, IP tables, rules, etc., to get the traffic across to the other gateway. But it only does that for traffic that actually needs to go to the other cluster. So all the traffic, all the network traffic that's inside your cluster stays, is still managed by whatever Kubernetes networking setup you're using. And so performance isn't affected for any of your intra-cluster traffic. So I'll do the same thing on the other cluster we have. So this one doesn't have the Submariner namespace yet because I haven't done anything Submariner related on it, but I will join. I'll change that now. So this one doesn't need the broker. I'll just join it. And so now we should see there, the Submariner operator namespace has been created. And now the operator pod is starting up. And a bunch more pods should appear. All right, it crashed, and so it's starting again. But while it's doing that, let's go and have a look at the objects that have been created. So remember, I showed a number of TRDs that are set up by Submariner. And so we have here the cluster TRD, and this is where clusters are described. And so we have, and well, there are two copies here for Athens 1. And so the first one is in the broker namespace. And so this is the shared information. So there isn't much at the cluster level. It's just giving the cluster name really, and deciders. So the ID here, deciders. And so this is the broker one, and then in the operator, this is actually just the copy of the one from the broker, because remember the gateway synchronizes all the cluster information from the broker to the various participating clusters. And you can see here Athens 2 just appeared, which means the other cluster has finished setting up. So we can see it all here, and it's joined. So the cluster 2 copied its information to the broker, and then cluster 1 copied the gateway in cluster 1 copied the information for Athens 2 to its local data store. And so now we should have a tunnel up, which means that if I go back to the NetShoot pod that we used earlier, so I'll start the terminal, and now at least we should have data plane connectivity. So if I do this, there we go. So here we have cluster 2 talking to cluster 1. But any guesses as to whether the service itself will work? And no, it doesn't, because the service itself isn't exported yet. And in any case, it doesn't actually use the same naming convention as standard Kubernetes services. But I'll come back to that in just a second. So some other things to look at here. With all this set up, we've got the gateway nodes running everywhere, the root agents running everywhere, and the tunnel is up. And so the tunnel by default uses IPsec, and we use a project called LibreSwan to handle that. Another option is WireGuard, which is gaining traction as a VPN solution, and that's usable already in Submariner, and we'll also be supporting soon unencrypted connections, because we have customers who've requested support for clusters that are connected using private networks, dark fibers and so on, and so they don't want to see reduced performance because of encryption on top. So we'll be supporting just VXLAN-based connectivity between the clusters. And another feature, which I'm not going to show, but which is quite useful. Remember I said that we have to designate one node per cluster as a gateway. Well, you can actually designate multiple nodes as gateways. And so that provides some level of high availability on the connection. So here we have an example with 2 gateway nodes. And the tunnel obviously is only set up between one gateway per cluster and the other clusters. But we have standby gateway nodes, and the gateways continuously ping each other. And so we do that for a number of reasons, but one of them is to make sure that everything's still up. And if something fails, then the passive gateway will take over and reestablish the tunnels. So this is what happens here. This node fails for some reason, or it loses its connectivity, and the other gateway takes over and reestablishes the tunnel. And ideally, there's minimal disruption to the traffic in the cluster. And obviously, if everything's been designed in a sort of microservice way, even if some traffic is lost, the overall service that's provided to end users shouldn't be affected, particularly. Okay, so we've got everything joined up now. The next stage is the second big component of Submariner, which is Lighthouse, and that provides service discovery. So up until now, we've been talking about data plane connectivity, but what happens at the service level? And so this is where Lighthouse comes in. And if you remember the pods I showed you here, we have a number of Lighthouse pods. So there's a Lighthouse agent and 2 core DNS pods, and they provide service discovery across a cluster, well, across clusters, multiple clusters. And so here's the architecture diagram for Lighthouse. So on the right-hand side here, you can see three dark rectangles. The first one is service A, and so this is a service that's hosted in this cluster and that we want to make available. And for scalability reasons, Submariner doesn't publish all the services across the clusters by default. Well, for scalability and privacy, security control, and so on. It's up to the administrator to publish services, and the administrator does so by creating what's called a service export. And this is just a very small object that's synchronized in the same way as other objects in Submariner through the broker. So it goes up to the Lighthouse agent that pushes it to the broker, and the Lighthouse agent and the other cluster, so on the green side of things here, sees that and creates another resource that's called the service import. And see, that's happened on both sides here. There's a service import on either side. And so then the Lighthouse core DNS will use that to resolve certain service names to the corresponding IP address, and that will make the service available. So I'll do that for the Nginx demo. So this is again handled with our subcuttle tool, which is called, well, using a subcuttle export command. So I just say subcuttle export service Nginx demo. So it's exporting it just now. Right, and so now it might take a few seconds for the service to be synchronized across, but now if I say if I curl Nginx demo, so it needs to be in a specific subdomain. So we have the namespace default, and then svc.cluster set.local instead of the local domain that's used in standard Kubernetes. And there, see, we get the Nginx welcome screen back. That's service discovery working, and so if we obviously, in this case, the service is only available in the other cluster, but if we set it up in both clusters, then each cluster will use the closest one. And if we had the third cluster, then it would round robin between them. So so that's sort of how to set it up, and I promised I'd show you the commands I used, so I'll come back to that in a little while. But before I leave the OpenShift screens, I wanted to show you some of the monitoring stuff that's available in Submariner. So there's a ton of features that are available to explore your cluster in Subcuttle itself, and I'll show those as well. But we also export a number of metrics. And so they're available for use in Prometheus and Grafana and so on. And they all start with Submariner in the latest release of Submariner, which is what I'm using here. And so, for example, we can show, we can keep track of the traffic across the cluster. So you can see that here, both RX and TX, so receive and transmit. We can also see the number of configured gateways. So you can see here, it jumps up when I set up when the tunnel came up. We have the number of connections that have been requested. So again, this is one when both clusters were joined. We can keep track of, remember I said that the gateways ping each other all the time? Well, they keep track of the latency between the clusters, and so you can graph that and set alerts on it, etc. What else do we have? We have metrics on the number of exported services and imported services. So here's service import, for example. So I've imported one service and it appears here. And there should be so on the other cluster, there will be an export metric as well, because this is where I exported the service. And that's it here. So again, this is pluggable into the alert monitor and so on. So for example, you could set alerts for the number of services if the exported services fall below a certain threshold, and so on. It allows you to keep an eye on everything. So that's it for metrics pretty much, and I'll switch to my terminal now. And I hope it's big enough for it to be readable. Is it okay for everybody?
Yeah, it's fine.
So you can see, if we look up at the history, there's the various commands that I used. So the first one here, deploy broker, that's the first one I ran to actually set the broker up. And it gives you feedback on what it's doing. Then there's the second step was subcuttle join, and I gave it a file, brokerinfo.subm, and this is generated by, just above C here, it's generated by the broker deployment step. And so it contains all the information that's needed to connect to the broker from all the clusters. So subcuttle join starts by loading this file, and that tells it where the other broker is. And then it looks at the cluster that is supposed to be configuring. It finds the configured gateway, it finds the network setup that's being used. So it detected here that we're using OpenShift SDN with these siders for services and clusters. Then it goes and checks some other information. For example, it will determine whether NAT traversal is required or not. And then it sets up everything that's needed and starts up the operator, and then the operator takes care of the rest. So in these two commands, and you just need to run it again on the second cluster, which I did here. These allow you to get the network connectivity up and running and service discovery started. And then to export the service, I just ran this. And so this is pretty, well, it doesn't do much, so it doesn't say much, just service exported successfully. And that's pretty much it. But if we run subcuttle help, you see there's a lot of other commands. So we used deploy broker and join and export. And there's quite a lot of others, so I'll show some of them. The first one is benchmark, so that runs a number of benchmark tests for throughput and latency, but they actually take quite a long time, so I won't show them. Cloud, this is a setup tool, so there are a number of features that we need to set up. For example, if we're setting up on AWS or Azure or GKE and so on, we need to configure things about the cloud setup beyond what a Kubernetes operator can do. And so this takes care of that. Then we have Diagnose. So this is actually, so I can run that. This runs a number of diagnostic tests. So the idea is here, if for whatever reason your connectivity isn't working, or your services aren't being exported, or there's something wrong with your Submariner setup, you just run subcuttle diagnose all, and it will go and check a number of things. So here it's checked that Kubernetes is recent enough for us. The network plugin is supported, that the gateway connections are up, that all the pods that we expect to see are running, It checks. So we haven't asked it to deal with overlapping CIDRs, so it checks that in fact that they do not overlap, because otherwise we'll have issues. It checks the kube proxy mode, it checks the firewall configuration, and so on and so forth. And so here everything should be green, so that's good. What else do we have? So Diagnose export we used. Gather I'll come back to. But then there's show. This is a sort of basic information command that tells you everything that Submariner knows about the current setup. So it shows you here stuff that we saw during the join operation, the network information that's been discovered. It also shows you the configured endpoints. And see here, it's able to tell, I've configured my kube config to only talk to Athens 1. And just by talking to Athens 1, which gives it the broker, it knows all the connected endpoints, even on Athens 2. And so it knows the endpoint IP, the public IP. And so you can see here as well, we've transparently configured NAT traversal because we have different IPs. It tells you what we call the cable driver. So this is the tool that's used to handle the tunnel, which one's being used. And you can see here which one is the local and which one is the remote cluster. And if we had more clusters, then there'd be more remote clusters configured. Then it shows the gateway, the connection information between the gateways. So this is the remote gateway. It's in Athens 2 with this IP address. We're using NAT. We're using LibreSwan, which is reassuring given that it's what's shown just above as well. And these are the subnets that are routed. So these are Athens 2's subnets. And that's good as well here because you can compare that to these. And so they're different. And we have non-overlapping CIDRs. And it also shows you the average round time trip, which gives you an idea of the latency between the clusters. And it repeats here the gateway status, and it shows you the versions of all the components that have been deployed. So this is 090, the latest release. So before I show you gather, there's another command that's quite useful, which is verify. So as you might expect, we have, for development purposes, we have a number of unit tests and we have a number of integration tests. And because they're all written in Go and Subcuttle itself is written in Go, we can fairly easily package them up and ship them in the tool. So this isn't just for CI, but end users can run the integration tests as well. So I won't show this because it's not all that interesting, but it's a sort of extra step in the troubleshooting if necessary. And then the last tool that we have, which is new in 0.9, is a tool called Subcuttle Gather. And so this is a debugging tool for us, really. If you go and set up a cluster with Submariner and things go wrong and you can't figure out what's happening, and so you file an issue or you ask us for help, you can run Subcuttle Gather, and that will go and connect to the clusters, or just cluster Athens 1 here, since that's the only one that I've configured in this terminal window. And it will go and connect to all the pods that Submariner set up and retrieve all the logs, all the configuration, etc. And so I have an earlier one that I set up earlier today, just to show you what's available. And so, yeah, so we have dumps of all the CRDs that Submariner uses. So here, the cluster from both clusters, the endpoints as well. The service imports, this is again, so this is from the broker, and then we have from different clusters here, the same information again, clusters, config maps, so this is for core DNS, then details of the actual deployments, so the daemon sets, deployments, then log files, again, more CRD dumps, etc. And the idea isn't for end users necessarily to go in and figure out what all this means, but it's a useful tool to get information back to us for debugging purposes. Right, and that's yeah. So that's pretty much it for the subcuttle tool. So I mentioned earlier as well that there was well, we follow certain nomenclatures that come from a project called the Multi-Cluster Services Special Interest Group in Kubernetes. So I'll switch my windows again. All right, and so this is actually, I don't know how familiar you are with Kubernetes SIGs, but this is how changes are made in Kubernetes. So there are a number of special interest groups that handle different domains within Kubernetes, like networking and so on. And so the multi-cluster services SIG is specifically for services across multiple clusters. And there's a KEP, Kubernetes Enhancement Proposal, which is number 1645, that documents the multi-cluster services API. And this is what Submariner implements to a large extent. And the idea is that by implementing this future standard API, because it's not standard yet, we can provide user experience that's similar across different tools. So it could be Submariner, it could be GKE, which supports the multi-cluster services API directly, or other tools like, I think Istio is planning to introduce this fairly soon. And so this provides a sort of standard terminology, for example, cluster sets, and it defines exactly what's expected from clusters that are connected. So, for example, one important concept that's used in Submariner as well is the idea of namespace sameness. And so this is the idea that a namespace with a given name, if it's found in different clusters, will be the same. So it'll have the same services, ideally, or the same services will be accessible at least inside it. And so that's why namespaces also feature prominently in service discovery when we're publishing services across clusters. It also describes how DNS is supposed to work for service discovery as well. And so Submariner doesn't yet implement this fully because this is still evolving somewhat. So we have, for example, there's a fairly recent addition, which is SRV records, which are going to be added so that we can provide port information as well as just IP address information for a given service. But it also describes the whole service export and import setup that I described earlier. And so this means that we can write the same service export object regardless of what the actual tool is. As long as it implements the MCS API, then that same service export object will result in a given service being exported. And then on the client clusters, they can look for service import objects and use them to access remote services, again, without necessarily caring about what the underlying tool is. Right, and I think, yeah, that's pretty much it. So everything that I've shown you today is described in the Submariner documentation that you can find on submariner.io. So for example, in the Getting Started section, you'll recognize the diagrams that I used describing the gateway, service discovery as well. And so if you're interested in Submariner, we invite you to go and have a look at submariner.io, read through the guides. We have quick start guides for a number of environments as well. Kind if you want to run it inside the Docker containers on your local system, K3s for similar purposes, GKE, Rancher, and then OpenShift on AWS, and more coming soon. And there are detailed operational guides as well, how to deploy using Subcuttle, using Helm, details of the various CNIs that we support with specific tweaks, for example, for Calico, monitoring information, troubleshooting guides. And if you want to get involved, lots of information about the community and our releases and our roadmap. So thank you for listening, and we've got some time for questions, I believe.
Thank you very much, Stephen. Very interesting. Guys, if you have any questions, please mute yourself, and you can ask directly, or you can write them down in the chat if you prefer. Okay, I have some questions. Perhaps while people prepare them, I can ask first. Stephen, can you place Submariner in comparison to other technologies somewhat similar, such as Istio, kubefed, or others, if they exist? I can cite those two.
Yeah. So Submariner is compared to, for example, Istio or kubefed. Submariner is fairly low level. It's more concerned. So initially, it was more concerned with data plane connectivity than anything like a service mesh like Istio would provide. And so we've added service discovery as well, but it's still well, fairly basic compared to what Istio can do. But in lots of scenarios, it's sufficient to provide what people need. And so there will be we'll be adding features to future releases. For example, one big request that we've had is network policies, which is missing. But obviously, if you need a full service mesh, then Istio is probably the way to go. And so we see Submariner as sort of complementary to service meshes. It fills a gap between individual clusters and full-blown service meshes. Compared to kubefed, the story is somewhat similar. And so, Submariner has it's more like a pool point of view for the administrator, at least. You set up services that you want to export, and then they're pulled to the various clusters, but Submariner itself doesn't actually create any resources, so it's not going to, which is what kubefed can do. So, like I said earlier, in the demo I had Nginx set up. With kubefed, you'd be able to say, I want to have Nginx everywhere in my cluster, and kubefed would take care of that for you. Submariner doesn't do that. So Submariner is probably more, well, if you need more than Submariner, yeah, other tools might be better, or Submariner can be used as a component with other tools. And so if we talk about products, so Red Hat, like OpenShift is our product for Kubernetes, and Submariner is shipped as part of another product that's called the Advanced Cluster Management. And that takes care of multiple clusters, and so Submariner is a component inside that. And then there are other projects that have similar goals to Submariner just in terms of connectivity. Projects like Scupper, for example, but the difference there is that they tend to they tend to provide network connectivity at a higher level in the OSI layers. So Scupper, for example, is mostly layer 7 based, whereas Submariner is really layer 3. So anything you can do at layer 3 and up, you can do with Submariner.
Okay, thanks. And what is the resources consumption of the different of the service of Submariner? I mean, I'm asking that to see
Yes.
how small resources. For example, I saw that you support K3s. Can we run Submariner on a Raspberry Pi, or is it too?
Yeah. Well, I actually have a. Yeah, there's a colleague on my team who runs Submariner on a Raspberry Pi 4, and it works quite well. Just looking at the pod resources here, what do we have? Yeah, so in terms of memory requirements, you can see it's fairly small. 60 meg, less than 60 megs for the gateway. Same for the Lighthouse agent. Core DNS is just a little bit bigger. The operator 70 megs, and then each root agent is around 50. And the CPU consumption is very, very small here. The most is the operator, which is using 0.021 cores.
Mm-hmm.
So yeah, it's fairly lightweight.
Yeah.
And the idea is really Submariner itself doesn't do all that much. It synchronizes resources, but it relies on all the Kubernetes infrastructure, like listeners, informers, and so on. So it piggybacks on top of that. It doesn't do much of its own polling, so it's not expensive in terms of just watching for resources. And then when changes occur, it applies those changes to the network. But once that's done, then Submariner itself doesn't need to do anything, and the network takes care of everything else. So it sets up the Linux kernel. So all this is running on top of Linux. That's all we support. But it sets up IB tables, and the IPsec for the tunnels or WireGuard, and then network traffic is just handled by the usual network layers without Submariner being involved at all.
Okay, I see. Any other questions, guys? I have some more, but if there are other questions from anyone. Okay, let me continue then. So if we have, I saw in the example you have 2 clusters, okay? What happens if we have 3 or 4? Do we still have one which is named as local, and then others that are remote?
Yeah, so that's that's an interesting question. So the local remotes thing, that's just when we ask Subcuttle to show us information. Subcuttle is always connecting. Well, I'll change the screen again. Show you my terminal. So when I ran Subcuttle show all here, I was connected to Athens 1. And so it says it's showing information for that cluster. And so everything that it shows afterwards is interpreted in relation to that cluster. And so the local cluster is Athens 1 because that's where I'm running. But if I run Subcuttle show all on Athens 2,
okay, yeah, I see.
On Athens 2, you see, so it says here it's showing information for cluster Athens 2, and Athens 2 is now the local cluster because that's the point of view. Yeah.
Okay. So if we need to have, let's say, services running on 3 different clusters, then we need to have the tunnels between all 3 of them.
Yes.
But what if one of them?
Yeah, if a tunnel fails or if you can't connect, so that's a topology that we don't currently support. So every time you bring a cluster into the cluster set, it has to join to all the other gateways. But that is something that customers have been asking for as well. So I imagine we'll be addressing it at some point. Because that could actually be quite useful if you have one cluster that's connected to everything, but you have other clusters that have limited connectivity. They'd still be able to access remote clusters. Yeah.
Okay. This is something that you have in the roadmap.
Well, it's something we have in the back of our minds. I'm not sure it's on the official roadmap yet.
Okay.
But,
okay. I see one question here in the chat from Chris.
The
what are the
requirements for the gateway node?
The gateway node, is it a software router?
So no, there aren't any special requirements for it. It's in terms of what it is, it's just another node in the Kubernetes cluster, but it has to be able to connect to the outside world. So wall setup has to be such that it can be connected to. So I'm just checking. I think we described that in the prerequisites. Yeah, so the gateway nodes, they have to be reachable over IP. So that can be behind NAT if necessary, but that's the main constraint. If that answers the question.
Thank you, Stephen. Yeah, sure. Thank you.
Stephen, a related question, if you don't mind.
Yeah, well, there's one already in the chat.
With the Kubernetes API for multiple clusters still in progress, how much production ready is Submariner? A question from
well, yes. So we think it's I've got two hats on, right? I work as an engineer at Red Hat, but my primary role is actually on the Submariner upstream project, and as a Submariner itself as a project, we reckon it's pretty much production ready, at least on the scenarios that we've tested a lot. So, for example, AWS, we use that all the time. So there shouldn't be much concern there. So that might be a little bit surprising given that we're still at 0.9 and our next release is 0.10 and not 1.0, but the big blocker for us the big feature really that we want as a milestone feature before we release 1.0 is to guarantee that upgrades are transparent. And it's not that our network connectivity features aren't great. They work fine already on the CNIs that we support, at least. So it's production ready as an upstream project. Inside for Red Hat, so as I mentioned, it's available as part of the advanced cluster management products, but not yet with full support. It's what we call a tech preview. But yeah, so if you use Submariner, the upstream project, it's as far as I'm concerned, it's production ready on the scenarios that we've tested at least.
There was one more question. I don't remember from whom.
From Alexandros.
That would be me, yeah. Thank you, Stephen, for the presentation, by the way. It has been very nice, and I really enjoyed it.
Thanks, you're welcome.
My question is, again, regarding the gateway. From what I gathered, this is an IPsec tunnel mode gateway. And in the past, one of the problem with IPsec has been always high CPU usage, and especially in a setup when you got a tunnel gateway, since this load is not distributed across the various nodes that participate in IPsec, but rather it's a focal point and a spot for a single point of failure. It can create scalability problems. You mentioned benchmarks, and I'd like to know more about, and you can just send me a link if you want, about how much scalable this is and what kind of traffic patterns and throughputs it can sustain. Thank you.
Yeah, so that's an interesting question and something that that's on the back of our minds as well. So yeah, so the impact IPsec itself well, at least on very high speed backbones, like 10 gigs per second and up, we see approximately 50% of actual availability over the tunnels. So you'd get on a 10 gig link, you'd get 5 gigs effective. That's including CPU usage. So we saw significant differences depending on the type of CPU that's available for the gateway. So if it's a fairly recent CPU with built-in support for encryption, then things are much better. I don't think we have any published figures, and our benchmarking tool just looks at latency and throughput. It doesn't measure, or actually does it? I'd have to check. It might measure CPU usage as well. So that you could run tests on your own setup if you're interested. And so like I said, it's something that's on the back of our mind, with perhaps the idea of being able to split up traffic across multiple tunnels between clusters, especially if you're in an HA setup with multiple gateway nodes. Then instead of just having an active-passive setup, it could be interesting to have active-active with traffic going across multiple tunnels. But yeah, it's definitely a valid concern. And so that's also why we want to add support for unencrypted connections. And then with IPsec, it's always point-to-point tunnels. With WireGuard, there might be some sort of more mesh VPN type setups that we could explore as well, but that's in the future.
So currently, what is the support of WireGuard exactly?
Well, you can configure it as a cable driver to provide tunnel connectivity instead of IPsec. It works pretty well as far as I'm aware. It's not something that I personally test much, but that we do have users of it. Yeah. So,
okay. Any other questions, guys? Perhaps one last one from my side, Stephen. What about the managed services, the managed Kubernetes services? I saw that there is GKE, but what about EKS or others from other cloud providers?
So we do. Yeah, so we have support for GKE, which is documented here. So GKE on GCP, that's a bit of a strange story for Submariner, since GKE natively supports MCS now, as of a couple of months ago, I think. But that's supported. There's Rancher as well, but then we haven't documented anything else, although I know that we have users who run Submariner on at least Azure, I think, AKS. Yeah, but that's an interesting question, because obviously, because Submariner is fairly low level, it can work. Whether it provides added value or not is a different question, because usually on managed Kubernetes, there tends to be built-in solutions for cluster connectivity.
Yeah, but what if you want to have multi-cloud?
Yeah, exactly.
Yeah, so
yes.
Would that work? Is it something that you are that your clients demand, for example, or is it something that you are not very much?
Yeah, it should. Well, it should work as long as the the basic components, if the gateways can see each other, then that's pretty much all you need, really. Then Submariner can do its stuff. So, but then so it'll work across different clouds. Where you can get friction, perhaps, is that administrators might want to use the cloud native tools for all their different managed environments, and so perhaps that's where the MCS API can come in useful once it becomes more widely available. So, at some point, I'd like to see, at least personally, being able to have a managed setup on GKE and use GKE's tools to export a service and have it show up in Submariner somewhere else transparently. But that doesn't work yet.
I see. Okay. I see one more question here from Georgios. What about offloading IPsec traffic to SmartNICs? Have you tested something like that? Yeah.
Yeah, so we haven't. There are other people working on features like, for example, DPDK with offload to SmartNICs and IPsec for Kubernetes connectivity. But as far as I'm aware, we haven't done anything with Submariner specifically on those. But yeah, that would be one way to improve performance, definitely. So yeah, so the answer is no, we haven't tested anything like that, but it's something that would come useful, and it'll probably happen at some point.
Nice. Other questions? And I see that, 15 minutes past 8, so, or 7 if you are in Central European time. Any other question, guys? Okay, if no other questions, then perhaps I can share my screen to do a wrap up. Let me check here. Okay. Okay, so a big thank you to Stephen. That was a really very interesting presentation, and it was very nice to see the demo and to know more things about Submariner. So again, as I said in the beginning, Submariner is one of the tools that we are going to use within physics project. If you want to know more about this project, you can check the URL here. And thank you to the sponsors for the meetup, Red Hat, Qubit, Canonical, and Riax. So thank you all for joining. Stay safe, and we are going to communicate with you in some time from now for the next Kubernetes meetup. Thanks again, Stephen. Thank you all. Have a nice afternoon.
Thank you for the invitation.
Goodbye, everyone.
Thank you.
Bye. Thank you. Bye.
Thank you. Bye.